Hey guys, this is a big one, the rational functions. So what is a rational expression? Remember, rational expression is the quotient of two polynomials. So rational function, what we're going to be dealing with today, is just two polynomials divided by each other. Now, we're going to look at them in standard form, descending order. N is the degree of our numerator. Remember, degree is just that highest exponent in there. M is the degree of our denominator. Again, that's just the highest exponent. A and B are our leading coefficients for our numerator and our denominator. We're going to need those vocab words in just a second. Now, P and Q are polynomials, and it's important that you realize Q is not zero. If it was zero, we can do anything in the universe exploding, blah, blah, blah. No dividing by zero, ever. Let's take a look and see what's happening. So let me just do this real quick so that we can reference that. Okay. So how do we do this? How are we going to graph? First, it's a rational expression. So just like we've been doing, factor it and simplify. Stuff's going to cancel. Now, when it cancels, we have to tend to it. But for the most part, it's going to be just what we've been doing. Factor it, factor it, factor it, and factor it, then simplify. After that, we're going to look at our intercepts. So x-intercepts, we're just going to look at the numerator equaling 0. Well, why not the denominator? Because that's not where the function would equal 0. That's where the function would be undefined. That's actually what our vertical asymptotes are, where the denominator equals 0. So x-intercepts, numerator equals 0. Vertical asymptotes, denominator equals 0. So remember, asymptotes, vertical, that imaginary dotted line you can't cross. Now the horizontal asymptotes have some rules you got to just remember. So you're going to be looking at your degrees of your numerator and your denominator here. If the degree of the numerator is less than the degree of the denominator, y equals 0 is your horizontal asymptote. Think about your basic reciprocal mother function. It's 1 over x, right? So my numerator has a degree of 0, my denominator has a degree of 1, denominator bigger than numerator, horizontal asymptote, y equals 0. Now let's say that n and m are equal. Let's say this is going to be the same. So let's say it's 3x over x. They're the same, right? So that means y equals 3 over 1, or 3, would be my horizontal asymptote. That's a over b. That's the quotient of these guys, whatever they may be. It must be in descending order, which I'm going to give it to you in descending order because there's no reason to not. Now, if the numerator has a larger degree than the denominator, there is no horizontal asymptote. That's when things start to get interesting. There's an oblique asymptote, sometimes called a slant asymptote. Now, there's only one special case we're going to consider this. Otherwise, you're just going to not even worry about it. I don't even think I'm going to give you any that have the numerator more than 1 above the denominator. But if the numerator is exactly 1 more than the denominator, then we're going to use synthetic division and get that little linear equation and find out what our slant asymptote is going to be. Okay. Now, step number 5 kind of goes back to step number 1. Remember when we simplified, we canceled some stuff? Well, whenever you cancel stuff, to take care of it, you're going to have to find out what you canceled, what that x value is. And wherever that x value is, you're going to have to put a hole, an open circle on it. So it's got to have a hole in the graph. When you're done looking at all this, you're going to have all kind of mess on your paper, but you're going to look and see something. It might be something you recognize. It might be one of your mother functions. It could be linear, quadratic even. It might be the reciprocal mother function. You'll see those a lot. If it's not, then you're just going to plug in points on either side of your vertical asymptotes. That's how we're going to graph these things. So again, a hole, that's just somewhere in your graph that you had to skip over, basically. Because whenever we canceled something, that means that was in the denominator. So whatever makes the denominator equal 0, you cannot have. So we got to put a hole there saying, hey, don't touch that. Let's just jump into it. So on your papers, you'll see all kind of mess over here. Don't worry about it. We're gonna work it out. We're gonna write the important information over here. No sense in you doing it twice. On Thursday's test, I will give a lot of extra space. So it'll probably be several pages long just for extra space for you to work. Step number 1, simplify. Can't factor, can't cancel, can't do anything. So it's simplified. Step number 2, intercepts. Start with the x, numerator equals 0. So that means x is 4. So that's the ordered pair for 0. Now with the y-intercepts, sometimes we'll use it, sometimes we won't. But it's real easy to calculate, right? You just have to ignore everything that has an x in it. I mean, if you plug in 0 for x, it's gone if it has an x in it. So negative 4 over positive 4 is negative 1. That's my y-intercept. So that's 0, negative 1. If this would have been some nasty fraction or something else, I wouldn't have worried about it. But it's negative 1. It's a nice number. I can plot it. Might as well. So that was your intercept. That's step 2. Now, step 3, vertical asymptote. Vertical first because that's the easy one. Don't have to do any thinking. You just take your denominator, vertical asymptote, x plus 4 equals 0, and you solve. Remember, the asymptotes are equations. So that x equals negative 4 is important. Now it's up to you whether you do it all the graphing at the end or if you plot as you go. I'm fine with either way. I'm gonna go ahead and start plotting some things so I don't get too terribly lost. I'm going to plot my actual points in blue and my asymptotes and holes and stuff in red. Now my holes are obviously gonna make open circles, but for now I'm just gonna go 4, 0, and 0, negative 1. So those are actual dots on my graph. I'm putting them in blue. So I know their actual points, you know their actual points, their actual points. My vertical asymptote is at x equals negative 4. I'm gonna go ahead and graph that. One, 2, 3, 4, and just a vertical line there, except I'm gonna put that in red, not white. And there we go. Now remember, it's an asymptote. It needs to be dotted. So if you're doing this on paper, just draw it and then erase some stuff. If you're doing it on Cami, well, put some little white lines on it or right click it and make it dotted. I don't care which way you do it, just it needs to be dotted. Okay, what's next? Horizontal asymptote. What did I do there again? Oh yeah, there's rules. Looking at our rules, we have to look at the degree of the numerator and denominator. Numerator has a degree of 1. Denominator has a degree of 1. That's the same. What did I do there again? Let's see. If they're the same, then I take the quotient of the leading coefficients. Okay. Oh, what's my leading coefficient here? It's a 1 and a 1. So my horizontal asymptote, y equals 1. Again, it needs to be dotted. That's not what I want to do. See, there's extra stuff over there. All right, so I'm looking at this. It's x minus 4 over x plus 4. I don't recognize that as a mother function. That's just, no, I don't know what it is. So instead, I'm going to test points on either side of all of my vertical asymptotes. I got some over here, so right side's good. I need to go on the left side. That's 1, 2, 3, 4. How about negative 5 or maybe negative 6?
Riley Burnett, report to the office. Riley Burnett.
Anything to the left of negative 4. Take your calculator, mash buttons. Remember, it's a good idea whenever you're plugging in things to put it in parentheses. So I'm gonna just stick -5 in there. And no, it would make absolutely no difference on this particular problem, but it's a good habit to have. 9, okay. The most important thing is it's positive, it's above my horizontal asymptote. So if 9 doesn't fit on here, that's okay. It should though. We just need to know which side of the horizontal asymptote it's on, if it's above or below. 1, 2, 3, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. So I know my graph is going to be in this region and this region. Just sketch it. It doesn't need to be that accurate. Let's have a nice purple color. And let's make it thinner. So I know it needs to get closer and closer to that asymptote, and somewhere it's going to curve along. Where at? I don't know. It needs to do something like this. Does it look like that? Probably not. I'm probably pretty far off. It's probably like over here or something. I don't know. Well, it's not there, obviously, but maybe over here. I don't know. And that's okay. You know it looks something like this. That's what matters. And this one's going to do something like this. I got 2 points. I'm going to use them both. And then I'm going to randomly curve down here somewhere. Try not to hit the asymptote. To kind of hit it there. It's okay. There, we're done. That's what it looks like. That's it. Go to the next one. If you notice, this is going to ask you for domain and range. Domain is just split up by your vertical asymptotes. Range is split up by horizontal asymptotes. We're not worrying about that right now. We don't have time for all that. Let's look at this. Okay. I can factor it. Let's factor it. That's 2 times x minus 3. Okay, nothing cancels. No simplifying there. So it's simplified. Step 1 is done. A little cold there. Yeah. So next, it's simplified, then no, not asymptotes. Intercepts those. So my x-intercept, x is 3. Y-intercept, plug in 0 for x, -6 over -1 is +6. So if you can get it, great. If you can't, or if it's a nasty number, don't worry about it. Y-intercept's not that important. These are just easy points to find anyway. I mean, they're key points, they're lovely points, but in the end, we're just sketching these things to the best of our ability anyway. And like I said, if you want to go along and plot as you go, that's fine. 3, 0, 0, 6. Okay. Now let me see here. Let me get my vertical asymptote. Yes, next. Bah. Denominator equals 0. That's weird. X equals 1. Okay, now I'm gonna go ahead and get my horizontal asymptote. Let's see, numerator degree is 1, denominator degree is 1. Hey, I remember they're equal, so I divide the leading coefficients. So my horizontal asymptote is y equals 2 over 1. That's 2. So now I'm gonna plot these two things. And my asymptotes. Pause first. In like 2 minutes, excuse the bell. All right, 3 more minutes after that. Sorry, it's gonna be annoying. Horizontal asymptote at 2.
Hailey Maxey, report to the office to check out Hailey Maxey.
Vertical asymptote at 1. And then we've got our asymptotes. They need to be dotted. There we go. I made that a little thicker. Who cares? It's fine. Where were we? We got the asymptotes. Nothing canceled, so there's no holes. I guess, well, we got a point on either side, so I guess we're done. Let's just graph the thing. Annoying. Okay, so it's gonna look something like this. I suck at drawing. It's quite all right. Something like this. And there we go. That's what it's gonna look like. Is that perfect? Not at all. Can I do better? Probably. Desmos could do a lot better. We're not using Desmos, sorry. I wanna see these by hand, people. I don't wanna see just random dots from Desmos. All right. Let's look at this one. Step one, step one, step one. Simplify. I can't do it. Wait a minute, what is that? That, my friends, is a difference of squares. Yes, factoring is still a thing. So if you haven't learned it for the past 5 tests, learn it for this one. That's gone. Now we're dealing with this. It cancels. That's gone and that's gone. So what does that mean again? It's down at step 5. I'll get there. Okay, so hey, I'm left with y equals f of x equals, who cares, function notation, blah, 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 x plus 1. I know what that is. Do you know what that is? I know what that is. That's a linear equation. That's what that is. So it's not rational. There's no denominator, right? So no more asymptotes. I don't have a vertical asymptote because there's nothing that would make the denominator equal 0 because there's no denominator. I don't have a denominator, so I can't compare the degree of the numerator and denominator to get a horizontal asymptote. It's just, okay. I just got a line. Oh, wait. What was step number 5 again? Oh, it's hiding. Let's scroll down. Identify your holes. So we got to look at the holes there. X minus 1. Canceled. So let's see what. Oh, this is complicated. Let me write it down. X minus 1. What makes that equal 0? I don't know. 42. Oh, no, that's just the answer to everything. X equals 1, right? Okay, that's just the X coordinate. How do I get the Y coordinate? Plug it in. Plug in 1 for X. 1 plus 1 is 10. Only if you're doing binary. It's 2 in base 10, though. So there we go. That's my hole at 1, 2. So I'm going to plot that. And since it's a hole, and I got this whole red is not their thing going on, I'll put it in red. So my asymptotes are going to be red. My holes are going to be red until I fill them in. 1, 1, 2. So this actually is not there. But after I graph it, I'm going to fill it in with some white and be good. Now my actual points, it's a line. It's in slope-intercept form. I got a y-intercept of 1 and a slope of 1. So I can do this, or I could do this kind of thing. If you don't know how to graph a line, just go ahead and scream at the computer right now. Okay, you done? Learn how to graph a line. Now this is gonna be my graph, so I'm actually gonna turn it blue. And it's gonna be something like this. But I'm gonna go back and I'm going to fill my hole in with white. Get this just right, perfect. Yeah, good enough. So yeah, I don't expect it to be perfect. Just if you're doing it with paper and pencil, just erase a little bit right there and put a circle around it. Fill the circle in with some white. If you got Cami, just open up your circle, fill it with white. You're good. Good enough. That's a hole. These things go on forever, and that's the graph. So wait a minute. That rational expression turned into a freaking line. Yep, they can do that. These guys are chameleons. They can become anything. So let's just keep looking at what they do turn into. The only way to do these is by practicing. There's no one way to graph a rational equation because you just got to see what it turns into. Could be anything. Like this guy. I know what this mother function is going to be. So I'm going to factor this. It's a trinomial AC method. I'll do it one time. We'll have to do it several times through here. I'm just going to do it this one last time. 29, that's 4 and 5. So put them over A, 4 over 1, 5 over 1. Denominator is your coefficient, so x plus 4 and x plus 5. That's the easiest way I can tell you how to factor for a trinomial, obviously trinomial. I mean, if you can just see it, go for it. If you know a different method, go for it, but this is what works for me. So now stuff cancels. So again, we're gonna have a hole. That's last, not worry about that right now. What does it cancel to though? It's a 1, right? So you have to make sure you don't put x plus 4 because that's not what this is. It's 1 over x plus 4. Hey there, little fella, I recognize you. We talked about you last week, you little mother function. That's the reciprocal mother function shifted left 4 units. So let's do that. I don't have to worry about any of the other pieces because I recognize my mother function. So I'm going to plot some points. The basic points are 1, 1, and -1, -1. And my asymptotes are at my axes. On my axes? They are my axes. Let's go with that. All right. But remember, we have to shift this 4 units left. That means everything needs to go 4 units left. This dot, 1, 2, 3, 4. This asymptote, 1, 2, 3, 4. This dot, 1, 2, 3, 4. This asymptote, 1, 2. Oh, that's not going to move. All right, so now we have this hole here. Let's take care of that. All right, be back in a minute. Come in. And we're back. So let's graph this mother function. So, oh, wait. Step number 5, don't forget it. Hole. So I'm gonna do it in red because it's not there. Let me make that a little thinner. X plus 5 equals 0. And obviously x equals -5. So I'm gonna plug that in here. Use a calculator if you need to. It's 1 over -1. That's just -1. So I need to plot a dot at -5, -1. Let's see, -5. Oh, this guy. This guy's not there. Get out of there, that guy, because you don't exist. You're a hole. So I'm going to now sketch my graph. Nice purple color. And it just goes closer and closer to your asymptotes and doesn't touch them. You could do the whole 1/2, 2, and -1/2, -2, and 2/2, -2, -1/2, but I'm not gonna be that picky. Just approach your asymptotes and you're good. And it doesn't need to be perfect. That's plenty good enough for me. Let's just take care of that hole real quick. So it's this guy right here. Actually, see if I can make it a little bit bigger. That's too big. So I got a hole right here. We got to fill it in with some white. Oh, beautiful hole. There we go. All right, so That's the reciprocal mother function with a hole in it. That's all it is. Let's go to the next one. So like I said, you don't know if it's going to turn into a line, reciprocal mother function, or some other random, who knows what kind of thing going on here. It's trinomial over trinomial, isn't it? That's two AC methods. That's lots of factoring. Okay, we can do it. And so I guess I'll do the AC method. I'll do the AC method on top, but not the bottom. Because the top one, it's got that 2 for your A, so it's, make sure you don't mess up on where to put the 2. So a -2 and a +1 are my factors. Put those over A, which is 2. Simplify. Leave it as a fraction. That doesn't simplify. So this guy right here, or right underneath, it's going to turn into coefficient addend. X minus 1, coefficient addend. That's the top. Now the bottom, AC method if you got to. Excuse me. If you don't got to, you don't got to. X minus 4, X plus 3. So that's factored. Now we can cancel and simplify stuff. Nothing cancels. Huh. Who cares? Factor it anyway. That's going to make the rest of our lives a lot easier, finding our asymptotes and our intercepts. Nothing cancels, doesn't simplify at all. That's simplified. It's a parabola over a parabola. I don't know what that mother function is. Just do it. Go step by step now. Number 2, intercepts. X-intercepts. X minus 1 equals 0. So X is 1. That's the order pair 1, 0. 2x plus 1 equals 0. X equals -1/2. That's really cramped. -1/2, 0. So this looks really weird. Let me just fix that a little bit. Now it looks more like 1, 0. Still kind of, I don't know. Who cares? Y-intercept. It's -1 over -12. That's practically 0. So it's going to be 0 at 12. Probably not going to need to put it. We might. We actually might. Under normal circumstances, I wouldn't even worry about that thing, but let's see what happens. I think something's going to happen interesting here because we got 2 vertical asymptotes. Yeah, we do. Vertical asymptote. X equals 4. You know, what makes this 0? And X equals -3. You don't need to show the work for that, people. You set the denominator equal to 0. You solve. It's basic. You could give me the intercepts. You could give me the asymptotes without doing any work. That's basic. You can do it. Now let me see. Horizontal asymptote. 2 and 2 for my degrees. So my horizontal asymptote is going to be my ratio of my leading coefficients. Remember that chart? Not yet, or you need to. Y equals that. Y equals sign was a Z. Okay. Y equals 2. 2 divided by 1 is 2. Need to trim my mustache, sorry. All right, so anything else? There's no holes to worry about. So for now, I guess I'm just going to plot this and see what happens. Let me start with my asymptotes. Let's see. I've got 4 and -3 for vertical asymptotes. And 2 for my horizontal. And it doesn't have to be perfect. I'm a little off. Close enough. Oops. Okay. Now my horizontal and vertical asymptotes are all dotty. Plot my intercepts. -0.5, 0. -0.5, 0, right about there. 1, 0, right about there. So we need something in between them because you see this is between two asymptotes? It's going to look either like, oh, excuse me. We're back again. Okay. So you see how it's between these two asymptotes? It's probably going to either look like a parabola or a cubic. Yeah, it's possible for these things to go through the asymptotes when it's really close to the 0 here. But if we look at this one, that's two x-intercepts, so we're most likely going to be looking at a parabola. So the only way we can do this is try and find a point between them. So, oh, hey, look, I have one, 0 at 12. Does it need to be accurate? Not in the least. It's going to be somewhere right there. Make a little parabola out of it. Beautiful. I got to get this side and this side, though. I have points on the right side of this asymptote. I have points on the left side of this asymptote, but I need them over here and over here somewhere. I don't know if it's going to be up or down or what. So let's find them. To do that, I'm going to plug in numbers. This is -3, so let me plug in -4, -5, 6, 7, whatever. Plug in something to the left of -3. Where am I going to plug it in? The simplified thing, which is the original because it doesn't simplify. You can either do the factored form or the non-factored form. I'm going to do the factored form. Nah, I'm going to do the non-factored form. Yeah. It doesn't make a difference at all, unless you type it in wrong. Now, again, whenever you're plugging in a number, put it in parentheses. I'm going to go with -5. Why not? I could go -4, but whenever we're close to the asymptotes, they're really high up, so it might not be nice. I'm going to go -5 just because it should be a lower number. Let's just do it. I don't know what it's going to be. I'm going to find out in a minute. Minus, again, put that in parentheses. And on the bottom, I'm also plugging in -5. And let me pause it one more time, sorry. 27 times the charm, let's continue this. Plugging in a number, yeah. So we're plugging in -5 into here, we're right here. Put it in parentheses, -12. And I get, hey, 3, that's nice. And if you don't get an integer, just round it to the tens place. It doesn't need to be accurate at all. Just need to know if it's above or below the asymptote, really. That's not round at all. We plugged in -5 and we got 3 out of there. Yeah. So now I'm gonna plot that, -5, 3. Yeah, about right there. Okay. Let me pick a number over here. We could do 5. You know, let's do 5. Because that way I can just go in here and I can change all these negatives to positives. And I don't have to type anything. See, I just hit the left arrow key there so I could get my previous problem back. Changing all those negatives, just deleting them really, and I get 11/2 or 5.5. So I plug in 5, I get 5.5. So 5, 1, 2, 3, 4, 5.5. Again, I got giant freaking dots. It doesn't need to be accurate at all. I just need to know which region it's in so I can sketch this thing. Now it's time to get sketchy. Yeah, something like that. Lovely, lovely. And something like that. And that. Marvelous. And what about this thing? The only way I can connect these dots is with a parabola, people. So let's make a parabola. But again, we got to follow those asymptotes. And yeah, sometimes some weird stuff happens right around zero on the x-axis, right around x equals 0. So we can actually cross the asymptotes sometimes. Not sure if we're going to get there, but if we do, you'll be able to see it because you'll have a dot over here and a dot down here, and you're like, what? That's what. So in the middle, crazy stuff happens. Not on this one, thankfully. Let's look at the next one. Oh. So I've got an x squared here. It's a GCF. That's going to be x plus 3. This guy, AC method, x plus 3, x minus 1. Canceling out, I'm left with x squared over x minus 1. I don't recognize that mother function. Nope, don't know who you are. Got to go the long way. We got a hole to worry about at the end. Don't forget about it. You cancel. So we got to take care of them later. For now, let's get our intercepts. So, well, x equals 0 for my x-intercept, obviously. X squared equals 0, x equals 0, whatever. Y-intercept is also 0. Okay, so I got a point right here. 0, 0. Plotted. Sorry, I put this in red. Let me see if I can change that real quick. Blue. Intercepts, then asymptotes. Now we need red. So vertical asymptote first. It's x minus 1 equals 0, so x equals 1. Put that, I'm gonna wait just a second though. Now let me look at my horizontal asymptote. That's a 2, that's a 1. Wait, what was it whenever the numerator was bigger than the denominator again? I forgot. Let's go look at our chart. Oh, that's right. There's no horizontal asymptote. However, there's one particular case we're going to be looking at, and that's whenever n is exactly 1 more than the denominator. So when the numerator is exactly 1 more than the denominator, which is what we got. We're going to be using we're going to be using synthetic division to find our slant asymptote. Oblique if you want. Here we go. OA. No ha, but an OA. And watch this anyway. Let's see. So what makes my denominator 0? 1. What are my coefficients? 1 and 0 for the x's, 0 for the constant. Bring it down and multiply. Combine, multiply, combine. Ignore your remainder. It was x squared. Now it's going to be x. Reduce the power by 1. That's going to be x plus 1. My asymptote is a linear equation. Okay, let's do it. So that means I got a y-intercept of 1. Let me plot it here. So this is y equals 1. X plus 1, sorry. So I got a y-intercept of 1 and a slope of 1. Something like that. Now let me go ahead and graph my asymptotes. Okay, no horizontal. I need a oblique. There we go. That didn't work out. Did I miss? I think I missed. Yeah, discount it. That's what happened. I actually love how you can just move things around on a computer. Wouldn't it be nice if you could do that on a piece of paper? Oh, hey, look, you got Cami, use it. And then a vertical asymptote of x equals 1. Okay, that's what my asymptotes look like on this one. I've got a dot there, but there's something missing. What's after asymptotes? Holes. I got a hole somewhere at x equals -3, in fact, right? See, +3 canceled, so x equals -3 is a hole. And let's find out where exactly that hole is. -3, and if I plug in -3 into the simplified thing, that's gonna be 9 over 2, 4.5, right? Let's just do it. We got a calculator, use a calculator. Yeah, oh, -2.25, no idea what I did. Oh, I know what I did. I messed up. That's why we use a calculator. -2.3-ish. Does not need to be exact. The main thing is, where is it in relation to your asymptotes? So let's see. -3, 1, 2, 3, -2 and then some. So, oh, wrong size. So right at 1, 2, 3, 2, and then some. There. That'll work. So that's going to be my hole. I need to, well, after I grab it, I'll fix it. Then I'll, right here, I need something in this right. So let me just plug in 2 real quick and see what happens. I need something, hey, I need something to the right of my asymptote. Oh, well, -3 then here, so let's just put 3. Just for laziness sake, and we get 4.5. So we have the ordered pair, 4, 4.5, 4. 1, 2, 3, 4. 1, 2, 3, 4. No, I can't tell what that is. I plugged in 3. My bad. Three, and then 4.5. Okay, now that one's got to be above the line. Sorry. Let's make this thing purple. Sketch this thing. Something like this. Some sort of weird hoop-de-dee, whatever. It's got to do some sort of curvy maneuver there. These are not straight. They're following the asymptote, getting closer and closer to them. Now, right here, we've got a hole, so let's take care of that. Boom, hole. Move on. So that's what this thing looks like. If we've got an oblique asymptote, it's slanty, so we're going to have like a squished hyperbola, I guess you could call it. Let's see. Simplify, factor out the x. Oh, x minus 6, that's nice. That means we've got a hole at 6. That's going to be 1 over Hey, that's 1 over x with a hole at 6. That's a mother function I know. We just did the reciprocal mother function. That's the basic reciprocal mother function. So we're practically done now because we know what that is. So we do have a hole at 6. And that would be 1/6. So it's 6. And a little bit above the line. Beautiful. Right there's a hole. I'll make it better later. But I'm going to plot my basic points. It's the basic reciprocal mother function. 1, 1, -1, -1. Asymptotes on the axes. Gotta hurry, it's getting a little cold. That was off. That was off. But I can fix it. Can't do that on your paper, can you? All right. Okay, so now I'm going to graph it. We know what the basic reciprocal mother function looks like. That was terrible. Something like that. Wow. Yeah, sure. Pretend it doesn't suck. Oh, it should be really curvy there, but you know what? I'm not an artist. I don't expect you to be artists. Just do your dangest. And make sure that's a hole right there. Boom. It's a hole now. Okay. Basic reciprocal mother function with a hole in it. Cool. We got a few minutes left. Let's just do it. I didn't do these in class, but let's might as well look at them. So AC shortcut in your head if you want. If you don't want, I'm doing it in my head. X plus 7, X minus 4, X plus 7, X plus 5. I'll go with this a little quicker. Cancels. Later on, we'll take care of that hole. X minus 4 over X plus 5, not a mother function I know. Find my intercepts. So I've got 4, 0, 0, -4/5. Probably not going to use that one. Unless I need to test a point or something, who knows. Asymptotes. X equals -5. Same degree, so the horizontal asymptote is y equals the leading coefficient's quotient, 1. Hole, that'll be at -7. Use a calculator. I should put it in parentheses. It won't make a difference in this case. I get 5.5. Plot everything. I'm going to start my 2 points. 4, 0. I'm on color. 4, 0, 0, and about -1. Might as well put it there. And then I have a hole at -7, 5.5. And now let me plot my asymptotes so I can see what the heck's going on here. -5 for my vertical asymptote. 1 for my horizontal asymptote. Oh, I can go ahead and graph the dang thing because I can see the shape now. Let's Gonna look something like this. Curving somewhere, I don't know where. This guy's got to come in and do something like this. I got to have a hole right here. Let me actually do this. And now I have myself a hole. There we go. So again, just take it piece by piece. It's kind of monotonous here. Let's see what this turns into. This one's going to be x minus 5, x plus 1. Oh, hey, that's nice. This one won't take long to draw at all. It's going to be 2, x plus 1. We've got a hole at -1. So this simplifies to, I'm actually going to write it out as a half x minus 5 halves. Hey, that's linear. I know that mother function. I can do it. -5 halves. So I'm actually going to plug in better points, like odd points maybe. Yeah, I'm going to plug in odd numbers just to see a better representation. If I plug in 2, no, that's going to give me a fraction. If I plug in 3, hey, if I plug in 5, I get 0. I'm going to do that. So I got 5, 0. That's my x-intercept, right? If you don't believe me, just do it. 5, 0. Lovely point right there. From there, I have a slope of a half. Rise 1, run 2. Or down and left. Now I'm going to go ahead. At -1, I have a hole. So at -1 would have to be right there because that's my slope. Now let me graph it first because it's going to go right through it. So this linear equation is what it turns out to be, except it's got a little hole in it right there. Ta-da! We did it! Yay! So that's everything. You have to know how to deal with your mother functions. You could have linear, you could have reciprocal. It's possible to have quadratic. Can't think of any instances off the top of my head that we will have it because I'm be kind of careful with these exponents because I don't want to deal with anything weird. So it actually won't be a quadratic for our class, but it could be. Okay. Yeah, so just go step by step. Find your asymptotes. Simplify it first, though. If it looks like something you know, then do it. And if you don't know how I got this, x is -1. Based on my slope at -1, -3 would be where the hole has to be. The end. Good luck. See you tomorrow.